So previously on the channel, we've shown you videos about bending steel conduit, 90-degree bends, back-to-back bends, double sets and swan necks. However, in this video presentation, we're going to look at some of the tools that we use in the electrical workshop in order to thread and deburr and connect the conduit to the actual system itself. The reason behind the video is I asked my level 1 and level 2 learners that aren't electrical apprenticeships to strip down their stocks and dies in order to remove the swarf that is created within the die itself and then reassemble them. However, after unassembling them, many of the learners couldn't put them back together. So it's inspired me to do this video to show you how to put together your stocks and dies in the correct order and also indicate some of the other tools that my learners have to identify under examination conditions to do with steel conduit. So if we bring the camera in now, let's look closely at how to put together our stocks and dies, and then some of the other tools that we're going to use in the electrical workshop associated with steel conduit. So here we have our completed stocks and dies, and it might be quite difficult to see on camera, but inside there is full of little offcuts of metal called swarf, and that needs to be taken out and cleaned because the swarf itself will damage the thread that we put in on the steel conduit with it, so that thread will be damaged by build-up of swarf. Okay, so my learners are required to break down the stocks and dies into its elements in order to clean it, and these are the elements that we've got. So we've got the stock itself and the handles, and they're simply screwed into the side like so and like so. So that's it. They're often called, that whole thing's often called the stock. So it's the handles added on. So we've got our stock itself. We've then got our guide we drop in. So the guide is dropped in next, like so, and it's important you get it the right way round. Some of my learners were trying to put it in that way round. We need the bolts themselves pointing up and our guide to be dropped into position like so. So our guide is in position. Next we've got the actual die itself, the bit that cuts the thread, and again they come in 4 common sizes, 16, 20, 25 and 32. We're using 20mm ones, and again it's got a little bit of swarf in there and that would need to be cleaned out before starting the threading process. And you notice it has got 2 little recesses in there, and they're really important we get those the right way round. On the back side you can see there is no recesses. So when we pull it up into position like so, we drop it in so we can see our 2 recesses there, and they line up with the bolts themselves, and then we just wind down the nuts. These nuts are not tightened off with a pair of grips, it's just tightened with the hand like so, and we've built our stocks and dies. Okay, so important things to remember to get round our die itself around the right way. It's 20mm in this case, and to remove all the swarf inside in order that we can cut our thread onto our steel conduit. So let's look at the next bit then. So we've got the thread on the end of our conduit, okay, hopefully done with our stocks and dies with no swarf in there, and it's important that we remove the sharp inner edge here on a finished end, and we're going to use a reaming tool in order to do that. We could use a round file in the workshop, and our students know that. We're going to use a reaming tool in order that we do that. This would be put into the conduit bending machine vise, and you'd ream out the actual end of the conduit to make it nice and smooth. Exam questions say if you didn't ream it out, what could be the problem? You could cause damage to the insulation around the conductors. And one of the questions is actually to identify that tool. That comes up as an exam question. We have to identify that as a reaming tool. We've also got a couple of bush spanners. Okay, both of them do both 20 and 25mm. So we've got 20 and 25mm, we've got 20 and 25mm in order that we can tighten up those bushes. Remembering in the workshop, the bush looks like this is a male bush, and we tighten it off like so into our box, or a coupler usually, or like so, yeah, in order to get it tight. Okay, so we've got a bush spanner. Again, I've seen in exam questions and at level 1 on a tool list where you have to identify these tools. So these are bush spanners, okay. We can mark our conduit. Last one for us is to mark the conduit. We can mark it using a scribe. Again, you'll be expected to identify that. And often on my videos, I've been using a permanent marker pen in order that you could see the actual mark that I put on the conduit itself. So generally you're going to be asked to mark a conduit or metalwork, that could be cable tray, that could be trunking, using a scribe. So we've looked at some of the tools that we're going to be using in the workshop. Important we work out how to build up our stocks and dies in order that we can unassemble them, in order to clean them out, and reassemble them in order that we can use them. So hopefully this whistle stop tour of some of the tools we're going to use in steel conduit. So in this video presentation we're going to look at some, not all, of the accessories that I use in the classroom linked to my notes when we're looking at steel conduit. So I'm going to bring the camera in, put it over the top, and we're going to discuss some of the fixing methods and some of the different types of conduit that I've got on the table here. So we've got some of the conduit accessories that I've got in my magic box off camera, a box I'll leave behind at Tresham College in order that students can touch, feel and look at the electrical accessories, especially those ones that are full-time learners obviously don't get a chance to use these in the real world. Our apprentices will. So if we start off with securing the conduit system, so in this case this being a black enamel conduit system here, I made this about 18 years ago when I first came into teaching. I'm going to leave it behind, but it illustrates the different styles of fixings for conduit, and under an old City and Guilds exam, it used to suggest why you would use each of the fixings here of these four. So we're going to still run through that. I still talk about that in my lessons previously when I was teaching at Tresham College itself. So what we've got here then, I'll try and keep it in camera, so I'll try and keep it in shot. So what we've got here is from bottom to top, different fixings, and the fixings mean how close it is to the surface. In each case, obviously it's a piece of wood, but there is a reason why we would be using each of these. So we've got, in this case here, just a plain saddle. So it's just really effectively the front of a saddle. They're all saddles, but all different types. This is a plain saddle. And the thinking behind that, maybe move it around this way, thinking behind that was it kept it very close to the surface. And the exam question in the old days used to say, when would you use a plain saddle? A plain saddle would be used when you're on a smooth surface like wood. So that's a plain saddle there. So we move along to this one here. This one here is a traditional saddle. Here's a galvanised version of it. Okay, this one being black enamel. So that's a spacer bar saddle. You undo the two little screws on the front, those two screws, and the saddle front comes off. You secure the back of it, so you secure the back plate onto the actual surface and then tighten the two screws up when you drop it on. So we use in the workshop. So we've got a spacer bar saddle here. So what's the reason behind using a spacer bar saddle? It raises it slightly further off the surface. The reason behind that, according to an old exam question, was where you had irregular brickwork. In other words, a brick wall will never be perfectly smooth. To allow for irregularities in it, you'd use a spacer bar saddle. Moving along to the third one, this is now bridged it even further off the surface, so we're a little bit further off now. This is a distance saddle. Okay, so you can see that it's a lot higher off the actual surface itself, the distance saddle. The distance saddle would be used where the wall is damp, so it creates a larger gap here, meaning a film of water wouldn't sit in here. So in order to bridge it off a damp surface, the old exam questions used to say you would use a distance saddle. And the very last one here is got the biggest gap. You see I clearly can get my finger under the conduit itself. And this saddle here is called a hospital saddle. It's slightly different in shape. It's certainly raised further up, and you'll be expected to identify these in exam by pictures and making sure you can see it sprays out at the ends here. They exaggerated on the actual exam question. This is a hospital saddle. So what's the thinking behind that? My students usually say, well, it's in a hospital. Well, that's not the case, because when I walk down the corridor to find the Costa coffee in a hospital, I don't see the conduits in the corridor secured using hospital saddles, but they are used in parts of hospitals. So areas of high hygiene, maybe in the medical theatre, maybe in the mortuary, maybe in the canteen areas, that you'd need a saddle that bridges it off fur enough in order to allow a cloth to go underneath in order to clean the conduit itself. I wouldn't recommend the conduit in a high hygiene area with this style of black enamel, but would be the thinking behind it is that in order to bridge it off further, we would use a hospital saddle for areas of high hygiene, food manufacturing, etc. So there are four common fixings. So if we turn it around this way, we've got plain saddle, smooth surfaces; spacer bar saddle, irregular brickwork; distance saddle, where the wall or surface is damp; and then at the bottom, hospital saddle for areas of high hygiene. We'll also talk about the crampet. We'll talk about that one in the classroom as well, and where we use that, as well as a girder clip. But the four common saddles are the ones I need us to remember in this part of the presentation. So let's put that back down. Conduit finishes. This conduit finish here, this conduit finish here is black enamel. Very, very rare. When I first started teaching 18 years ago, all the conduit systems that I put in were in the workshop in black enamel. It is a steel pipe covered in black glossy paint, and you might not be able to see, but over the years that paint has started to remove and it's actually pitted out, it's started to corrode. So with the conduit system black enamel, whenever you scuff it, you must repaint it in order to prevent corrosion. So that's black enamel. We've got the commonest conduit now that we tend to use, and we use it inside and out, but the exam questions will talk about it for other reasons. This is zinc galvanised. It's not galvanised conduit, it's galvanised with zinc, and the exam questions will say, in order to prevent corrosion of a conduit system, What do? You add zinc to it in the zinc galvanizing process. So we've got black enamel, zinc galvanized. The third one on the table here, it almost looks like chrome, it isn't. It's stainless steel conduit, quite expensive. Again, this would be used in areas of high hygiene, in food manufacturing and processes, where there's a lot of cleaning down of the actual system itself. So we'd be washing this down regularly. We'd be using it in those areas. We'd be using stainless steel. There is a fourth one in my note called sheradised. Sheradised is similar to the galvanised, but the zinc is actually impregnated within the actual steel itself and not just coated on the surface. We'll cover that in the classroom. That would be sheradised. So, black enamel conduit, we'd use that inside in dry environments, according to the exam questions, very rarely used now. When would we choose zinc galvanised? We choose it where the area is damp or maybe on the outside of a building, but certainly not on the outside of a building somewhere like the seafront at Blackpool, because obviously the salt air would be corrosive even to the galvanised. That's maybe where sheradised comes in, and we'll cover that in the classroom. And again, stainless steel, we'd use that in areas of high hygiene, food processing factories, etc. So there are three common, sheradised being the next one up. We've got two different types. Will we be able to see it on that one? Maybe not too easy on that one. Let's see if that one, right. I'm hoping now you'll be able to see. If you can't see it now, you'll see it in the classroom. There is a line that runs down the inside of here. It's probably about there. That's a line. If you can't see it, you'll be seeing it in the classroom. If you're not in one of the Tresham lessons, have a look in the end of your conduit and you should see a line running down it. That's because this is seam welded. So in other words, it was a flat piece of metal rolled into a tube and welded. And that's the most common. So the most common type is seam welded steel conduit. They do a solid drawn one. Solid drawn one wouldn't have the line coming down it. It'd be pulled or extruded from one piece of material, so it would have no line. So what's the difference? Just quickly for this video, it'll be explained more in the classroom. If you needed a gas tight installation, one where there's atmospheric gases like fine particles of powder, fine particles of paint, okay, or vapor, in order that then systems don't have the gases penetrate through the conduit, which they will on the seam welded type. In order to make a gas tight installation, use solid drawn. We'll explain that a little bit more in my notes and in the classroom. So just remember, two different types: seam welded, solid drawn. You're very, very likely to be only using seam welded, especially in a college environment. Conduit lengths, any of these here, so stainless steel, black enamel and zinc galvanised, come in a standard length. Bit controversial now. Over the times they've changed that standard length. It used to be that steel conduit was the exception to the rule. A full length of steel conduit used to be 3.75 metres, old 12 foot. Actually, as time has evolved, electricians have said, well, we can't get those in the tubes on top of our van. So they've actually reduced down the full length now to 3 metres. Be careful. The questions that I've got in the eFix Apprentice Hub, there's about 1,200 and there's about 600 in the installation theory section to help you with your exams. I still state in there that steel conduit comes in 3.75 metres. Until it becomes the absolute norm, it's a 3 metre length. I'm going to leave that question as it is. So just remember, a full length of steel conduit is probably now 3 metres when you get it from electrical wholesalers. It used to be 3.75 metres. So we'll just name a couple of the other accessories. We've got couplers, okay, we've got couplers. We've got female bushes, okay, and we've got lock rings. I've got a male bush on the table, so I'll just see if I can find one of those. So I've got a male bush, okay, so that's a male bush, and this is a female bush, and we'll be using both of those in the exercises I've laid out in the workshop in order to connect, say, to a coupler, okay. We'd have a box in here and we'd cut time between the two. We've got lock rings and lock nuts. We've got different types of accessory. So in this case, you can see we've got a black enamel and a galvanised box. This is often called on site an end box. It's actually a terminal or a termination box is the proper term, but of course we all call them end boxes. They've got a pre-threaded spout. So in other words, the conduit itself would be threaded, like this one here. Conduit would be threaded and goes into the spout itself and then would be tightened off. So you'd wind it into here, tighten that off, okay, in order to make the connection. In order to get into a coupler, there's a thread in there as well. Okay, so you just wind it onto there, make sure it goes on tight, and then that would be connecting those together. Conduit itself comes in different sizes, the size being the actual diameter, not the area, the diameter of the conduit itself. The 4 common sizes, so I find it difficult to say every time I say it, 16 is allegedly a common size. So it's 16, this isn't, this is 20, 25, which this one is, and 32. So you've got to remember that 4 common sizes of steel conduit are 16mm, 20mm, 25mm, and 32. We're talking about the diameter of the conduit. I'll just throw the next one in. Next one in is the bending radius. We'll talk about that in the classroom, it's in my notes. The bending radius of this conduit is a multiplication of the diameter. So the diameter in this case being 20, you have to multiply it by 2.5, that gives you 50. You'd set 50 into your compass, draw yourself a circle, and that would give you the radius. I've done a video on how to do bending radiuses of twin and CPC, steel or armoured, mineral insulated, etc. Uses exactly the same process, but it's the multiplication of the diameter of the conduit by 2.5. A couple of other boxes. We've got a T-box. We've got a back entry or loop-in box, and this is a 4-terminal one. They obviously do other ones with less holes, so like a 1-terminal or 1 hole loop-in box, and things like angle boxes. We'll go on my notes to talk about things like tangent boxes and where we use them, etc. This is just a whistle-stop tour of steel conduit. I'll do the same on plastic conduit to link to the notes that I've got. So let's have some key features to remember. 4 common sizes, 16mm, 20mm, 25 and 32. Standard 3.75, maybe 3 length of conduit. The fixings themselves come in this way: hospital, distance, spacer bar, plain. Smooth surfaces for plain, irregular brickwork for spacer bar, damp surfaces for a distance, hospital saddle for areas of high hygiene. The finishes themselves: black enamel, zinc galvanised, stainless steel, and sheradised being one of the others. So that's a whistle-stop tour of some of the stuff that we'll do within the notes that I've produced for Tresham College. Remember, those notes can be passed out. Feel free to contact eFix and look at the Apprentice Hub, and maybe even nominate your college for an eFix visit from me and Joe, and we'll happily come down to your college and I can pass on any information that your lecturers or the learners need. So what I'm going to do is I'm going to bring the camera in, I'm going to put it over the top, and I'm going to go through some but not all of the things that are in my notes that cover plastic conduit and will come up potentially at your exams as you move forward. So let's bring the camera in and let's have a look at what we're going to see. So I've done a very similar video on steel conduit, and we're going to run through some of the same sort of things on that as well. So if we talk about the sizes of plastic conduit, remember in both cases it's the diameter of the actual conduit itself. So it's not millimeters squared, it's not the area, it is actually the diameter of the conduit. Exactly the same as in steel. The 4 common sizes are 16, 20, 25 and 32. So it's 20mm, 16mm, 32mm and 25mm being the diameter of the conduit itself, often used as an exam question. They come in 2 standard colours, which is pretty obvious from the table: standard white and standard black, but there must be a reason why we have 2 differing colours. So we've got to think about the actual locations of which they're going to be installed in. So black PVC conduit for exam purposes will be in things like industrial environments where there's likely to be airborne dust, or maybe people with filthy hands, some parts of motor vehicle workshops, etc. would be the type of question they would say. So you'd use black conduit where it's potentially a more dirty environment, and white PVC conduit where we're talking about things like offices. So it's more aesthetically pleasing to see a white conduit maybe against a cream wall. So there's another couple for you. PVC, remind you from earlier videos we've done, PVC stands for polyvinyl chloride, and exactly the same as any other PVC, it's got to be installed at a temperature above 0. Okay, so the PVC conduit is left on site, maybe outside in a freezing cold winter, falls below 0. You must leave it in an ambient temperature above 0 for 24 hours before you can install that conduit system. Again, that used to be an old examination question, so that's worth bearing in mind. It can be left in an ambient temperature below 0 once installed, but it can't be installed at temperatures below 0. Okay, so we've got those. We've got the fixings of it, okay, the standard spacer bar saddle. We looked at this when we looked at steel conduit, is pretty much the only saddle you're really going to be working with plastic conduit. So again, the 2 little screws come out, we fix and fasten the back plate to the surface, and we put the conduit in and we return the 2 very small screws at the front. So that's our spacer bar saddle. It comes in types, so it comes in its gauge. So we're looking at the thickness of the walls, and it's difficult for you to see here. So if you're looking at the thickness of those walls, okay, to get two differing gauges. So we're talking about it being light gauge and heavy gauge. The plastic conduit that I use in my workshop is heavy gauge, high impact, and we suggest being high impact, it can withstand the blow from a hammer. They suggest that if you're using light gauge conduit, that means the walls are a lot thinner, that it must be potentially reinforced by something else. So if you were installing a conduit system in a screed of a floor, in other words, in a concrete floor, you could get away with using light gauge PVC conduit because the concrete floor would be protecting the conduit when installed. But all the conduits we use are heavy gauge, high impact. They come in a standard length. This is not a standard length. They come in a length of 3 meters long. So that's pretty traditional for all of the systems now, really. Steel trunking, cable tray, ladder, basket, plastic conduit, mini trunking, dado trunking, skirting trunking, all in a 3 meter length. We did suggest that steel conduit could still come in a 3.75 meter length, but does also come in 3, so that's in a different video, so it's worth picking that up. We're going to tend to fix it into locations like boxes, and I'm sure you're doing it in the workshop using these adapters. So we've got to work out the difference between the two adapters. So this one here that has a bush that's removable and goes inside like so, that's our female adapter. Okay, so we've got a female adapter, and then we've got one that has a ring. Okay, so we put that then into a box or electrical enclosure, and then the ring on the inside. And that one is a male adapter. Remembering they do them in 16, 20, 25 and 32 mil adapters. So that's a male adapter. This one's a female adapter. Boxes are very similar to those in steel conduit we looked at before, and they're in my notes as well. So it's just an example of 3. So we've got in this case, 20 mil black PVC T-box. Got a through box, and one that we often call an end box, but it's usually called termination or a terminal box. So that's our conduit end box. So how do we secure our conduit into here? We cut, clean, square our ends, etc. at the right length, and they're pushed into place into here. But actually in the real world and not in the workshop, where we're just obviously just pushing them in and leaving it. Okay, so that one's a little bit broken then. So yeah, just pushing it and leaving it, obviously because we like to use the boxes again. In the real world, that's not the case. When we're going into the box themselves or into our adapters, we're going to need to secure them into position. And we secure them into the position using a PVC solvent weld, in other words, an adhesive. Okay, and the exam questions will say, when working with PVC solvent weld, what must you ensure? You must ensure that you're wearing the appropriate PPE, so appropriate gloves, maybe a mask because it's got quite a vapor with it, and goggles. The last thing you want to do is obviously put some of this into one of your eyes. Okay, so that would be it, and along with things like making sure you're in a well ventilated area when using it. So if I slip my gloves on just so somebody didn't pull me apart on social media, they'll tell me they're the wrong kind of gloves. I'm sure they are, but they're the only ones I've got for the video demonstration purposes. And if I was to open this up, another exam question used to be, when applying the adhesive, where do you apply it to? Do you apply it to the inside of the box, or do you apply it to the conduit itself? Well, we actually apply it to the conduit, so we would apply it to the actual conduit itself, round like so, and then we would insert it into the actual box itself into position. The reason we don't insert it into here, just putting the glue on the inside here, it can fall between the gaps, so it could come and make a barrier, making it very difficult to poke the wires in where the glue has fallen between them. So we're actually going to put the adhesive, the PVC solvent weld, onto the actual conduit itself when it goes into these styles of fixings. What else have we got in front of us? We've got this. This used to come up as an assignment question, and it's called an expansion coupler. What's the thinking behind an expansion coupler? The thinking being that it will allow for changes in ambient temperature, and what would happen to the conduit as it gets hotter or colder, it grows or shrinks. So in warm environments it again tends to get a little bit longer, and in cold environments it tends to get a lot smaller. I'm sure there's something else you can think about that works in the same way that you own, that in warm weather is a lot longer than it is in very cold weather. So very similar process here. And what happens is, one of them is pushed into place, that's as far as it goes in, so it only goes in that far, and that would be glued and held into position there within the expansion coupler itself. The second one goes in, but doesn't go all the way down to here, so it can go all the way down to there, so it would therefore go in that far. You don't put it in that far, you put it in approximately halfway, but what you do is you apply on the outside here some sort of petroleum jelly, so in other words some sort of a mild lubricant, in order that it will allow it to slide in and out with changes in ambient temperature. So what the exam question used to say is long straight runs of 6 meters, so in other words 2 lengths. In order to stop it buckling, in other words losing its shape, what do we need to insert? We need to insert an expansion coupler. Expansion couplers are secured at one end, can be glued in here, and the other end is allowed to freely move in and out from its position. So if I just put my finger there, so we're going out and in from that position, okay, in order to allow for changes in ambient temperature. We've got an inspection box here. We'll talk more about inspection boxes both in steel conduit and plastic conduit and the thinking behind those. Obviously, there's a chamber here that we can remove. Our cable system can be pulled out of here and pulled back in order that we can wire in semi-straight runs. Okay, so we've got we've got inspection boxes. We also have inspection elbows, etc. And we'll show those in the workshop and in the classroom, and they're also within my notes itself. So as I said in the previous presentation about 4 times, that's a little bit of a whistle-stop tour of some of the accessories that you'll see within my notes and within the electrical workshop and within your practice on site, and get familiar with them, but get familiar with the sort of things they're going to ask you under examination conditions. Sizes of conduit: 16, 20, 25 and 32 millimeters. We're talking about the expansion coupler. Can you describe how it works? With it being fixed at one end, free to move in and out the other end. The fact that we apply the adhesive to the conduit itself and not within the actual box. It comes in 2 standard colours, black and white. It needs to be installed in ambient temperature above 0. All those type of things and plenty more will be discussed within my notes and within the workshop and classroom sessions to prepare you for your installation theory and therefore onto the working life itself. So that quick look at PVC conduit, I just hope these videos have been some help.